In the next hour, we're going to talk a lot about different ways to deploy Docker containers to Azure. And there are several ways. My name is Michele Bustamante. I run a security and microservices practice out of Soliance, and also am the co-creator of Policy Server, a joint venture with Soliance. We spend a lot of our time, and I spend most of my days doing both security and microservices related deployments around the security topology. I work with some of the best people I've ever met, honestly, who do this across many platforms, Amazon, Azure, different clusters. So, I guess what I would say about that is hopefully I can share or impart with you a couple of the things that I feel are the most important that you get to know, no matter which orchestration platform you may or may not deploy to with Docker, and give you some tips and tricks around that as we go through a tour of several of the places and ways you can deploy Docker to Azure. So we're going to start with a couple of questions I hear quite often. The first of those questions is typically, do I even need an orchestration platform? Is that necessary for me to, do microservices or do Docker? And the second question that I get is typically, how do I know, so besides how do I know if I need an orchestration platform, how do I choose between the orchestration platforms once I've figured out I actually need one? And this is getting a little bit easier, to be honest, now that we're getting more managed services. But I'm going to take you through the reasoning around what are the features we care about in orchestration, what are the ways we might deploy things before orchestration to sort of give you, some foundation in making those types of decisions. So first, a tour of what do we have in Azure for microservices, for Docker deployments. We have serverless options. Functions now support being deployed as a container. And we also have Azure Container Instances, which is the one I'll focus on in this quick round tour, because this is the first-class citizen in Azure, the container. Single line of code, deploy containers, really nice, and it goes serverless. So we'll talk about that. PaaS, which means platform as a service, which means managed servers so that you don't have to worry about patching and operating system updates and things such as that, among other features. We have app services for containers, which I'll talk about. We have Azure Kubernetes Service, which is a new managed service for Kubernetes. And then we've got Azure Service Fabric, which is more for your native plus container deployments. Which is an option when you're doing Service Fabric for the features that it offers, like the stateful services and actor-based models and things like that. So then we have IaaS. So IaaS just means really roll your own, right? You take a platform you'd like to use, and you deploy either DCOS or Kubernetes or Swarm mode with Docker Enterprise or Docker Community Edition. And there's a number of other options as well. So we get some templates out of the marketplace, and that can kick us off, but ultimately you're going to own the template when it's time. So what I'm going to do first is we're going to start with a quick TLDR Docker, just in case there are folks new to it, and also to bring home some of the things we care about when we think about running containers. And just kind of a high level, right? Docker is a containerization technology. It popularized and made mainstream the working with containers, right? We had Linux containers before. And then, of course, with Docker, now it's become accessible to Linux and Windows, and also easy to use, right? It's got developer tooling, it's got runtime tooling, it's got DevOps tooling. And so it's a way to package your applications and deploy them as containers. You put all the dependencies inside the image, so basically there's no more issues of configuring machines with lots of software moving parts. And you can also do multi-container deployments with it, and you'll see a little bit of that. We have a runtime environment that has to exist in order to run a container in a Docker on a host machine. And then, of course, when you develop your software and you package it in a container image, then that should be able to run anywhere that has Docker available. We have the idea that any of these orchestration platforms, aside from just a host machine with Docker installed and the Docker engine available, we have container platforms that also support Docker, which means that they've got the container engine running as well as some other things to help you manage the deployed containers. So we'll talk about those things as well. One of the main things that we get out of Docker is that full stack encapsulation, which gives us two really cool things. One, of course, being anything that I need to run my environment, and actually let me start with, you're going to have a base image, which is identifying a compatible host for your Docker container. So, the kernel's not included, right? It's a base image without the kernel. It's lightweight. And then on top of that, you might install some security patches to that and create a new base image. And then on top of that, you'll deploy your dependencies. So a .NET Core app might have .NET Core, ASP.NET Core, and Kestrel for the reverse proxy to receive requests. And then we've got our application files that get deployed somewhere with an entry point, right, to reach it through the proxy. When we do that in Java, it would be maybe just a different set of tools, right? I might have Apache Tomcat on top of that and have the Java SDK and then my Java application and maybe some other moving parts. And then, of course, I can have Windows Server. I can have Nano Server or Windows Server full for full framework, migration, lift and shift with a Windows container orchestration cluster, okay? Of course, all of this includes the Docker engine on a host that is where you're running these things, okay? Now, the goal of all of this is that whatever works on your machine, you build this image, the full stack is encapsulated, all the dependencies. I'm an expert at ASP.NET Core, someone else is an expert at Golang, another is a Java expert. Whatever polyglot language they want to work with to build the end result doesn't really matter anymore, and we can combine those things, and it will work on their machine and hopefully everywhere else, because we finally have achieved that with the consistency of that image being immutable and essentially just deployed wherever it goes. So that's a beautiful thing. And so with that, let's talk a little bit about how I work with Docker. I'm going to have my app code. Maybe I have a web app and an API. And I'm going to define a Docker file that will describe how to build the image. What are the dependencies? And with that, I'm going to hit I'm going to give the instruction Docker build, and I'm going to tag it with a name so that the image has a name to be used when I run the container. I tell it to look for dot, which means the Docker file in the folder or something else if applicable. And then the output of that, of course, is that I have my web app or API image that has been generated, probably for now stored locally as I'm developing, and then eventually will be pushed somewhere that is accessible to my cluster or my deployment environment. So I build images from my source. I describe a Docker file. That's my development process. And then eventually we want to run those things. So we take these images that we've built, and we go ahead and, with a Docker run command, tell it to run this image and maybe give it a name, of course, so that it has some way to be reached in the environment. And then we maybe map the internal port of the thing that's running, assuming it's a web app API, and map it to an external port on the host. In this case, I'm mapping it to the same one. And then I give it a name of the image to run. So there are a number of other things I can provide the run command, which are relevant to the environment that we'll get into briefly after this. But the simple view of it is I'm taking the image, I'm telling it to run, I'm probably letting it assign a dynamic port or a fixed port, and then I end up with this running container that I can communicate with, hopefully, yeah? So with that, there is the concept of a service description. When I run a service anywhere, whether it's local with Docker run, or whether it's deployed to some environment, ultimately, it's a task, it's a service description, it's an application description. These terms are interchangeable depending which orchestration environment you're working in. I need to describe how to run this thing. I need to talk about port assignments. I need to talk about if I want to join a network so that I can communicate internally to my APIs from my web apps, let's say, without exposing them publicly, for example. I need to be able to say any environment variable overrides, because those are the things that will change as you go through environments. And I might have a number of other things in special cases where I have maybe volume mounts, or I have Docker secrets instead of environment variables, right? Because I want to make sure those are protected in a different way. And there's a number of other potential configurations. Those things are part of describing the service as it's going to be run. And so in the world of Docker, Docker Compose is the file. You can create a compose file, which is described in YAML. And it is the service description for the Docker Enterprise and Docker Community environment running in swarm mode. And when I say I want to run maybe one or more services, I describe it in this compose file, and it will go build the Docker file, images, and then it will run those images collectively as an application, a multi-service application. So I take you through that because it's a very important feature for a number of reasons. One being when I'm local, and let's say I wanted to onboard any of you to a project I'm working on, if I can say install Docker to your Mac or your Windows machine and go, git pull and now compose up, I can create an environment where all of that just runs. And so compose up gives us this onboarding of developers just as a developer tool. Forget about even orchestration. And it's worth pointing out, right? So I might have multiple apps, multiple APIs. We're developing all of them. And maybe some of them I'm building and testing in Visual Studio. And some of them I'm not, and I just need to pull the image and run them so they're available to the run testing. And then I might have some dependencies like maybe local Elastic for testing or local Kafka for testing message event-based systems. Local pgadmin if I want to do Postgres, or just a relational database that's lightweight on my, machine. And the point there being, I can even have, Docker containers that run and initialize the data. So literally, git pull compose up, beautiful thing. So it can describe these multiple applications to run locally for development, but that same thing could theoretically be the instruction to deploy and tell the cluster, I need you to load up all these services for me. Make sense? Not to say that all of those database services would go into your cluster, but the point is it can be, a collection of services. So I want to show you a couple quick things with just working with Docker, and we'll start with that as a way to kind of just look at the compose experience. So what I'm going to do is go to my directory on Docker, and let's go into one of my simple examples. And what I'm going to do is I have a web app and an API. So what I'm going to do is go into my web app and just give you a quick look at the Docker file. So we'll do a cat Docker file. And you'll see that what this is saying is I'm building a lightweight Alpine Linux compatible base image, and I'm exposing port 3000 for this web app and installing curl because I need that for the health endpoint. And then I'm saying, hey, let's have an intermediate image. This is multi-stage builds available with Docker to flatten the images, make them smaller. So I'm now going to get a base image called, a node base, because this is a node app. And I'm going to install Bower, and I'm going to do the npm install, and that's going to produce a bunch of files and modules and things. And then the output of that is going to go into my final base image, and then I have an entry point to start the app. So when I run this, that's how that app gets built, that's how the containers get built, and et cetera. So what I can do now is let's go here and let's cat the Docker compose file. And so this simple compose file says, hey, I've got an API, I'm calling it API demo as a DNS name, and I've got a web app. And I have an override in my environment variable saying, find the API at API demo :3000, because it's an environment for this local machine. And so this would be the thing that changes as I traverse environments, but I wouldn't have to touch the image. I wouldn't have to touch the Docker file, because that would just be about building the image. So when I run this as a compose up experience, now I have a network created by default, unless I want to name it, and this will give me my web app and API communicating with one another. So there you go. What I'm going to do now is just take a quick look here, and we'll do a Docker container ls. And I've already got this running, so the other interesting thing about this is you can do a Docker compose down, and what that will do is shut down those images. And then when I do a Docker compose up D, which just means run it as a daemon, it will go ahead and restart those. If the images weren't built, it would go build them first and look for those Docker files, because the compose file said, where's the Docker file located? And so now I should have this running if I do a Docker container ls. And then you can see that I have these two things running here. That actually might have been a different one, kind of think of it. And if I kind of scroll over here, you can see it's port 3000 I've mapped to for the web app, and port 3001 for the API, which was my override. And then if I pop on in to one of these guys and just type localhost 3000, then this will take me to the running app. And this should take me to being able to call the API to show the speakers and sessions, which is what that API does. And if I'm, if DNS is working and my compose file had that properly described as an environment override, everything works, okay? So that's a quick tour, just to give you that compose description in order to sort of set a baseline, if you will, for this process. So the container registry is the next thing we want to talk about. I just built images that were on my local machine in the local cache. And that's where they live while I'm just doing local development. But ultimately, if I want to deploy these things somewhere, I have to push them up to a registry. So my local build, or I can do this with CI, I'll show you, will basically take the image, and I could write an instruction on the command line and say, push the image to this registry, Docker Hub, Azure Container Registry. So Azure Container Registry supports that for our Azure deployments, and it's a secure registry. And there's a lot of nice connectivity between that registry and our VSTS for easily building and pushing, and connections between that and other Azure assets for hosting. So you'll see that when I go through some demos. So the image registry, we need to push the image to. Ultimately, we're also tagging these images. So the tag is very important for understanding which version is this, which one is latest. There can only be one. We might have other repository tags related to perhaps the build number. We could have a numbering and naming convention for feature releases. Could be any of the above. So when I push to the registry, I can build all these tags and push, and that will happen. Or I can go in and set up a CI process, and I can go to, say, VSTS with Git behind it, GitHub, go to GitHub, go to TFS. Whatever my CI tool of flavor is, really, all of them could work. And basically, you can either tell the CI tool, go build now and push the image, or it can automate, of course, on check-in, where it will pull latest, build the image, so it needs to find the Docker file, and then it will push those images to the registry of choice as you configure it. So that's a useful thing to do, and ultimately, the goal of that is that the tagged images will land in one of my environments, right? So when I'm testing, I might have a dev environment in the cloud, and that should automatically probably get latest. And that's the only one, by the way, should always get latest, because anywhere else you might cause a problem you're not expecting quite. UAT and prod, maybe those are specific versions or labels, and we explicitly say we're ready to do so unless we're in a full-on automated check-in, everything goes process. Those are decisions you make. Once I push the images, the tags are the things we're going to ask for in the environment, and it will automatically keep that environment up to date if it's pulling latest all the time, or if you tell the environment, here's a new tag, please go get. So these are important concepts to have baked. And let's just talk really quick about how we could do that in Visual Studio. So I actually have a sample here that will maybe have a bug in it that I'm going to fix. So right now, I'm forgetting my base address to return the speakers in one of my deployments, right? So what I'm going to end up doing here is I just made a change, and I'm going to not even test it locally and commit, because I'm a loose cannon. So let's go ahead and say fix speaker bug. I know it works, didn't test, okay? I'm not saying do this at home, just having a little fun. So I'm going to sync this, I'm going to do a push, and with that, I can go over to my environment here, and we should be able to see that there's a build down process, right? So essentially, when this builds, this will go ahead and start to, let's see if we can go into the existing one that's running, yeah? And this will start showing the output, right? It's going to go through the process. Eventually, it's going to build the image and push the image and so on, right? So I've already configured this to connect to my Azure registry. It's really easy to do, so that's cool. Obviously, in an hour, not going to go through that. But what I'm going to show you next is, let's go to the registry. So in here, what we should see is that my API is going to get an update, or actually, sorry, let me correct. The front end will go from 341 to the next number. And so that will eventually, populate. And if I had any, assets out here in Azure that were automatically pulling latest, then that would get up to date, okay? So that's the idea. Okay, so we've done a crash course in Docker, right? We know we have to build the image, we know we have to push it somewhere, and we know ultimately we're going to run it somewhere after testing locally, perhaps in Docker Compose Up, right? So let's take a look at some other things we care about. So among those is, of course, well, do we deploy one container and just, have it at port 80. And essentially, because containers restart so fast, and because we're a startup and we want to conserve cache, maybe we just have one machine out there with the container and we're happy and ready to go. But no, we're not going to do that because we need load balancing. So let's move along and talk about how that happens with a Docker and a container environment. So, load balanced environment, of course, you would expect that, there's some Azure load balancer in front that is forwarding requests, maybe round robin or otherwise, to port 80 at each of these web machines, 8443, right? So with that, when the request comes in, if I have a container listening at 80, remember the Docker run command, then I would be able to receive at either of those machines. And as long as every machine had an instance of that same container at 80, then it's going to work. It's going to find one on each machine. Just traditional web app deployment, right? Now, of course, if I have multiple containers on the VM, my challenge is I can't share ports, so I would have to choose a different one. And that's not ideal for production. It's something you can work around initially, but we need DNS, right? And we need routing. So if we continue through the idea and say, hey, what would happen if I have, multiple containers and I would like all of them routed through 80? Then what I could have is an HA proxy router, an Nginx router, or something on the box that would receive requests at 80, look at what was being requested, either DNS or routes or paths, and basically forward it to the right one internally. So that's another option with a poor man's sort of setup, without putting in the effort to go to some other mechanism. But web apps for containers, which is a PaaS environment in Azure, and Azure does PaaS very, very well, has a built-in solution for that with DNS. So every time you deploy a new container to the PaaS, even if it's on the same machine, each of those will get a DNS. I'll just call them ABC. And so every time you scale out, each of those will get the same DNS. And then the load balancer knows which DNS you asked for, and maybe you map that to your own DNS. And then that will eventually get to the right container on whichever machine it landed on. We still have the scale out. Every container distribution looks the same. Every VM, every host is going to look the same. So we're still with the same limitations there. So we haven't yet done a discussion about server density, right? I'm still needing to look at, hey, how could I make better use of those VMs? But for now, we're just saying, hey, this is easy. I understand PaaS, I understand, app services in Azure. It's easy for me to manage, but I want my containers to go there, and I'm not ready for an orchestration platform yet, because I haven't learned enough about how to manage that, or, maybe we don't have enough containers to worry about that yet. So this is a great option. Again, it's PaaS, it scales out just like app services. It can give you only 8443, so those are your limitations for the deployment. And so let's take a look at what that looks like. So I'm going to head into our environment for Azure, and I think let's see what we can take a look at first. So I actually have app service containers already deployed here. But just for this interest of seeing how we would create such a thing, right, I'm going to go ahead and add, actually, let's go back to where I was there. I'm going to go ahead and in this resource group, add a new, app service for containers. There we go. And we'll say I want to create that, okay? So here, I'll call this SM demos NDC new web app. And what I can do is I can choose an existing app service plan so that it's actually sitting on top of an existing VM, or I can create a new scale out set, right? So I can create a new app service plan with a different set of machines. And then ultimately it's asking me what's the container going to look like. So, I can either go for a Docker Hub deployment that's private or public, some other private registry with username and password, or my Azure Container Registry, which is this one, and I can choose an image, like another copy of the web app, and I can tag which one I want. So I can go back a version, right, to some other instance that exists. And you'll notice now we have 342 here, which is kind of neat. So let's go ahead and deploy that one. And once this is deployed, then, we'll be able to reach that at port 80, and it will, basically, I haven't yet set up the CI part, right, like that would automatically pull latest, but I could set that up as well. So let's go ahead and first get the deployment going, and I'll head back in here and we'll take a look at the finished one. How about we don't do that just yet? Almost there. Okay, so right now I already do have this app service plan, and it already has a web app and an API deployed. And if I take a look at the apps, the web app has a container setting. And you can see that it says I want continuous deployment, and it should automatically update. It takes about 15 minutes before I see that. So if I want immediate result, then I could recycle the container and I would get the bug fix that I was talking about. So that's one part of it. The other part is the app settings. It always does that. And I will have an override somewhere in here, right, for any of my app settings for the container. So let's see if I have that. This is the new one. Maybe it's the new one. Let's go over here. So this is my DNS it gave me, and it's still, again, on the shared machine. And when I head in here and I hit the speakers and sessions, as long as the config is there for the override, then everything should work fine. And there it is. So what's it hitting? It's hitting the other container, right? So I showed you quickly how to deploy a new one, but I had already the setup so that you could see that you can communicate with each other. They're on the same machine. There's no special communication internally on the machine. It's going through, DNS to come in and call the API. And then I'm going to be able to scale this out. And I would just have to have, of course, this is my VM. They're all going to have the same containers on it. Scale out. It's a copy. Okay? All right. So keeping momentum. Azure Container Instances. So now, what about one command to just launch a container, don't care where the server is, the serverless concept? And that's a beautiful thing because maybe I have some bursty loads around certain types of processing in a container. Probably, could include just a web app or an API that sometimes gets a burst and needs to scale out as well. Or it could be something that's processing messages, and we need to scale that out when there's a long message line in the queue. Serverless, of course, we don't see the servers, but they're there. And the idea is I'm just launching a container. I'm getting some warmed area for it to be hosted, and I'm getting, DNS access to it so that it can scale. So load balancer in, scales out however many it needs to, containers available. And I can also do multi-container deployments, which might start to sound similar to the compose file capability, which really just means with Azure Container Instances, just like with Docker Local and Docker Swarm and Docker Enterprise, you have a way to describe a service deployment. And that way would be ARM-like right now, and this could evolve to where it's actually taking, in fact, I think they just launched at Build this week, taking a compose file as an option. So this is kind of where we're heading. We need to describe the service. We need the overrides for environment variables. We need to know if there's multiple services in the deployment so they can communicate with each other within their own network and not have to go out through DNS, for example, private APIs, and other such things. So with serverless, I'm running this command. It's deploying those wherever. It still has the environment override variables and things in the service description that it needs. And there's a few other things that will add, but let's keep going. So with an Azure Container Instance, I still have, these things deployed to a service, but what I can do is I can go into the UI and I can create a new one, a new Azure Container Instance, and I can tell it which container, but you'll notice it's starting to ask for interesting other things, like, is this Windows or Linux? Because that's supported, and that way it'll find the right home for the container, which means my base image probably matches either Windows or Linux too. And then we also have, look at that, number of cores, amount of memory. What's that? These are other things you can tell the environment about your container. How much memory and CPU do I expect to consume to run so that the scheduler can decide where should I be hosted? Where should I go? Who has room for me? Which machines are best? And there's a number of other constraints we can provide. So those are really important things, and just starting to open the door to that discussion. So with Azure Container Instances, let's go in here for a sec. I'm going to drop back and take a look at something of a description. So if I go to ACI, and let's open up Notepad, Content, Demo, Deploy. And you can just see from a high level, right? This is a description. No need to memorize all of this, obviously. but it does show the CPU and memory requirements. It does show the environment variable override for the web app to the API. And notice this localhost, that's because when I do a multi-container deployment, right now the way that works with Azure Container Instances is it gives you DNS with localhost to the port. And that might evolve, so hold that thought. The point there is, this is just a task definition, right? So I can deploy this, and if we take a look at how, let me cat the deploy, and this is just a single CLI command, AZ group deployment create. I could do this from the Cloud Shell if the JSON is available to me somewhere publicly or on my Cloud Shell, or I can do it from here. So what I'm going to do is I can notepad that, and I'm going to just edit it to do a new deployment. Oops, that was weird. Let's do deploy multi-bat. And what I'll do is I'll just call this deployment, 3 or something like that, just to not stomp. And the other thing is it needs to have a resource group that's pre-created at this time. So I might say I'm going to create a new SM demos NDC-ACI, okay? And that resource group needs to exist. So I'm going to head over to my Azure environment, which is over here. And I'm going to go to my resource groups. And we'll just go ahead and create that resource group to start. So add one. And ACI, I could have scripted that, by the way, right, creating the resource group, but I just wanted to kind of go through this visually a little bit too. So here, SM demos, NDC, ACI, and we'll create that. I think East US should work. You have to pick a region that is allowed. And once this is there, resource group, then we can head back to my notepad, save that, close it, and then cat. We'll just do a deploy multi-bat. Away we go. And it's running. So once that finishes, it's going to head over and we'll see the deployment happening in the portal. And at some point, we'll be able to, see that it's finished, and then the API and the app will be there. In the meantime, let's just take a quick peek at other things we can do. So if I go back to my resource groups and head into the ACI, we can see that I can also deploy, a brand new one, right? So I could say I want to create a new instance, probably is a good search term. And we'll go here, Container Instances, and say I want to create that. And with that, container name, SM demos, live, ACI. Just giving it a name. Container image, public or private. This is where it's interesting, right? So if I go to private, it will actually not give me the drop-down right now. So I'm just going to go with public. And we'll say das blind content web, or content web. That's the website. So I just don't want to go through the nonsense of typing all the rest in. Most of the places actually connect you directly to your registry, though. So I'm sure that'll come. And then I'm going to say I'm going to use an existing resource group. Which one? Actually, I don't care. We'll just say new, NDC, new RG. And we'll deploy. And this will, say what? That's interesting. A little not expected. I guess I'm going to have to get out of there, huh? Okay. Maybe a feature just updated in the portal. It's possible. Choose Windows or Linux. Choose how many core, public IP, any DNS names you want. There's a lot of things that just lit up this week, not surprisingly, because of build, right? So there's some new things you can do that we were not able to do before, right here from the UI. So you'll notice the screenshots in my slides were slightly less features, so it's starting to evolve in the portal. And so while that's deploying, let's head over here again. And that gives you the idea of how easy it is to, from the UI or from the command line, quickly deploy a container. Ultimately, that means it's getting scheduled by Azure. So I probably eventually want a way to visualize that. And the way that's going to be is through Kubernetes, because Kubernetes has this thing called a kubelet, that will let you visualize external things. And there is an experimental GitHub repository right now that already has that available. It's called an experiment only because I guess they're trying to make it clear that it's not ready for prime time just yet. But that's going to be beautiful because then I can have my serverless things that scale wildly, and then I can also have, you know, the ones that I'm deploying intentionally that's using fixed nodes in my cluster. So, you know, that's sort of where we're heading. As far as the previously deployed application, if we take a look at the overview here, you can see I didn't put any any DNS. So I'm just going to have to go here to 3000. And it'll still show me that it's working, which means it's doing that internal localhost DNS and everything's fine. Okay? All right. So now we start to get interesting because we can do all this stuff. I have containers. I can run them locally. I can push the images. I can deploy them into PaaS, which is nice and easy and accessible to somebody who knows Azure but doesn't know orchestration yet. And then I can have these loose containers that run and do stuff, but I probably need a management story around that still. So we need to talk about why would I move to orchestration. So we can do things without orchestration, but we need orchestration for things like service discovery. You know, the idea of not having to know that every machine has a service at port 80, at this DNS. You know, I need to be able to distribute the services wherever and have them somehow enlist or register and tell the cluster, here I am, so that we don't have to have this, you know, fixed set of the same apps on every node, for example, and use the servers more wisely and have better server density. And that's a really, really important feature. The other is load balancing in general and routing in general, which all comes with the platforms in different ways. And then there's auto-scaling the containers themselves. So, hey, this one feels busy. Why don't we add some more? Or this one doesn't have enough running yet. How about we make sure there's always two? Things like self-healing when something fails, when it crashes, restart it. I've seen that be incredibly useful in situations where, you know, there was a memory leak, for example, in some Java container that was running, and until you figured out the leak, at least one thing happened. It restarted. And so, you know, every day it restarted at some point, but, you know, that didn't used to happen in our IaaS web app deployments. The nodes just came down. So these are really nice features, upgrading and rollback, so being able to deploy new versions of containers but not have it affect the running app, have it gracefully deploy and stitch up the new one and retire the old one. Secret management, so that your environment variables don't have to hold secrets. So all those features are the things that we're going to think about. I'll show you some of them as I go through the platforms. And then the other thing is, of course, under that is infrastructure somewhere. I either manage that infrastructure or I don't. But it's there, right? I have, you know, master nodes and agent nodes, and there's obviously got to be, you know, some form of DNS and load balancing on the outside, and a registry to deploy my images to. And then I have platforms that support this, the features of the platform itself to do the deployments and scheduling and orchestration. So Kubernetes, Mesos DCOS, which also supports Kubernetes. Docker, you know, Enterprise, which also supports Kubernetes and Swarm. Service Fabric, which is not Kubernetes, more native .NET with containers with its own scheduler. When we think about the host environment in Azure, we've got the Kubernetes service, which is managed. We've got your infrastructure as a service, which is deploy whichever platform is your flavor. And there are reasons to choose. And then we've got on-prem hybrid, which is a really good reason why people maybe don't go with PaaS, because they want to manage on-prem the same as cloud. So they need to choose, do I want Kubernetes, DCOS, Swarm mode CE or Enterprise? Do I want to pay for a license and support? That kind of thing for on-prem and cloud. And then we have Azure Service Fabric, which is also now PaaS, more PaaS-like than it was before as of this announcements this week. So there's a lot to think about there, but ultimately, you know, what we want to do is understand why orchestration as we go. And so orchestration gives you these master nodes. Their job is to keep track with quorum, where are all the services, what is the healthy state of the services, what is the state of the nodes, And do we have enough services running? Is there, any of them need to scale or not? That kind of thing. And the master nodes have a leader, and there's leader election when one goes down, so they stay current with each other. All of the clusters, all of the orchestration platforms have this concept. Whether you see the nodes or not depends how far into paths you're going. We have agent nodes. That's where we deploy our stuff, but we don't talk to agent nodes directly. We tell the master, deploy this. Here's my service description. Here's the services I want you to deploy. Here's the overrides for environment. Here's how many services are bundled together. And then it does the job of figuring out where to push those things and deploy. So scheduling is a very important part of this process. Scheduling means I'm essentially issuing a Docker run or compose up at the master with some sort of CD tool or directly with command line. And that will then let the master say, okay, how much resources do I need? Who's available? You guys, go pull the image and run. Here's your parameters, get it done. And then the nodes take care of it from there. And when the nodes run those containers, it registers with the master, essentially, who tracks where are all the services running, so it knows these two services are on those two nodes and healthy. And then there's a heartbeat that goes on, so that if they get unhealthy, the master knows that too. So there's this whole process of registration that provides a way to do discovery, which means you could send a request to the cluster and say, I want application A, and that application could be on 2 of the 5 nodes, and it knows how to find that. Scheduling services means server density, means I don't have to know which node everything's on, and I can fill up the nodes better because now I don't have to have a copy of every service on every node. And then, of course, as I'm doing scheduling, if there is a kind of a heavy population of services and we start reaching our thresholds for CPU and memory, disk space, of course we need autoscale to start sending messages to Azure to say I need more nodes. And then now I've all of a sudden got some space, so I can shuffle things around a little bit so they can literally move and optimize how things are deployed across the board. So this is a beautiful thing because now we have room for new instances and that thing can get deployed and away we go. So the master keeps track of all this stuff, helps the deployments happen and get scheduled, keeps track of health, and at the end of the day, they all follow a similar path. Now, if I do this with IaaS in Azure, then what I'm getting is essentially the master nodes and the agent nodes, and I'm going to directly see and pay for all of them. So a first deployment would, for example, be like minimum 8 nodes, right? I'm going to have 3 masters because I need quorum, and I'm going to have probably at least 3 to 5 nodes, so probably 8. So another reason that people would start with paths and app services would be, I don't have enough containers to populate all that, and so why would I pay the cost of 8 nodes? But if you're really invested in microservices, it's going to be pretty easy for you to eventually have an 8-node cluster, and that's what you're managing on-prem and cloud. So IaaS supports that story. We used to have something called Azure Container Service, which still shows in the portal, but is probably going to disappear as that name, because it really was just ARM templates that kicked off deploying DCOS, Swarm, and Kubernetes. And it would give you a cluster like that based on a template by the vendor, and now the vendors are going to start managing those templates more themselves, and it's just going to be part of IaaS. And then you would, of course, customize that template anyways. You're not going to take what they give you and say, okay, my Azure setup is done. I mean, you own those nodes. You have to do all the things you do when you manage any infrastructure in Azure, patching the machines, updating the software, et cetera, et cetera. So is that all bad? No, not at all, because sometimes you're doing on-prem and hybrid, and you want the same experience on-prem and hybrid, so I would certainly choose then between these, and now I have to think about, which way do I want to go? Docker native, because they can give me a support contract and it's supported by the company, so I'm going to spend money. Large organizations do that, right? Because they don't want to be without support, a lot of them. So they'll go for the support contract with Docker Enterprise, possibly with Mesosphere, right, with DCOS, because they also do that. And then others will be like, you know what, there's a lot of mind share around Kubernetes. I'm going to figure that one out, and it's open source, and I don't have to pay for the support. Or the same with Docker CE, which is Swarm. Okay, so we get these ARM templates we can deploy, and it'll do something like this. But at the end of the day, what it's doing is this, right? Management nodes, agent nodes, where the software goes. All good. So I'm going to give you a tour quickly of each of these. And we're going to talk about different things as I go through it, one of them being constraints and how we deploy. So I'm going to talk about Swarm first. So let's get out of here. And I'll go into, and I'm going to connect to my Swarm cluster. Okay, so what I'm going to do first is, essentially what I've done is I've securely tunneled into my Swarm cluster, but I'm going to pretend I'm coming in from outside and send instructions to the Swarm cluster. Because if I type, for example, Docker info here, it's going to tell me about this, this particular machine, right? So this is my Swarm master, you see? So that's what this machine is. And if I type, Docker container ls, it's going to show me that I'm running Swarm and I'm running console, which is the key value store that's keeping track of the state of things, right? And all of them have that. But more interesting is this. If I type info, but I do it against the cluster, against the master, I'm basically sending a command to the master, and it's telling me about my cluster. I have a Swarm agent with 2 containers, another Swarm agent with 1 container, and another Swarm agent with 1 container. So what I'm doing is instead asking questions, if you will, about the cluster. So if I wanted to do a container, okay, so I'm going to do this, container ls, and this can tell you that these are the containers that are running across the cluster, but each of them on a different node. So when I talk to the master, I'm getting the whole picture of the cluster, basically, is what I'm saying. So I can issue commands to deploy there, like, say I want to run this content API, and I'm going to hit that run command, and it just ran another one. So I should be able to see that I have another running. But what gets interesting is also when you do things like this. How about a constraint? 7 gig of RAM I'm going to ask for, okay? So now I'm going to take that idea of the CPU or memory requirements. I'm going to pass on the Docker run against the cluster and say, I require, 7 gig of RAM. So let's give that a run, and let's give it a run a couple times. Don't mind the daemon error. And it says, no resources available to schedule. Now, I'm doing this from the command line. I haven't sent the right instructions to say retry and all of that, so it's just going to fail on me here. But obviously, in the actual deployed environment, what your clusters are going to do is keep trying. We'll see that. So let's come back up here, and let's do another Docker info. And if I do that against the cluster, I'm now going to find out that I have containers running, but also 7 gigabytes reserved, you see. And I've now said, this container needs 7 gig, so don't put any more on there, right? So that's how you know, basically, how much room you have left to spare in the cluster as a whole. And your first question is going to be, how on earth am I going to know that? And the quick answer, given the hour, is that, you're going to do drills, right? You're going to take a swag. I think probably I need 1 CPU. Maybe we can go down to half. And I'm going to go with 256 meg, instead of gigabytes. And, something that uses more memory, you have, again, general idea. And then you're going to run tests and loads, and you're going to start to learn, how do we break that container? How do we tip it? How do we make it fail? How do we make it run out? And you have to do that. That's part of the job. Otherwise, we're just doing what we used to do, which is deploy stuff, and, the node might crash one day because somebody's taking too many resources. So it's part of the job. And that's where I'm going to leave that for now. So let's take a look at actually one other thing. So I'm going to exit here. That just sort of illustrates the basics of, constraints, right? Deploying and saying, this is what I need, and what does the impact to the cluster, which means I can't deploy. I'm scheduling, and I can't find resources. The other thing that I can do, though, and let me just grab my other shell, is I can take a look at, the orchestration UI in front of that, right? Like that command line is what you would do with Docker Community Edition. There's no UI, there's no tools, but everything's command line, right? And a lot of people use that because it's native Docker. And the other thing we can do is go into an enterprise environment. So let me do, I'm going to go into conference demo 2. Okay, so what I'm going to do is cat this just to show you what it is. And what this is doing is saying, I'm going to import a module that's going to let me connect to the cluster, basically. And it's going to take from this folder information I need to connect to the cluster, the SSH key and all that good stuff. And then I'm going to cat demo. And all this is doing is it's going to try to do a deploy to that cluster, okay, in a folder called conference app 2. It's going to deploy a stack, which is essentially a bundle for deploying Compose. And let me go over here to my UI. And I have this loaded up over here already. I should still be logged in. Let's refresh. And what you'll see is I've already got a conference app deployed, but I wanted to show you, again, instructions get sent to the master. Now I'm seeing a UI in front of the master. It's on the master. This is the UI deployed to the master. So either way, I'm having a master, I'm interacting with the master to know what's going on, how many services are deployed, how many images are available, because this has its own registry as well. It's telling me things about the nodes, how's the health of the node. All of them will do that as well because they know what they're reserving. And then if I head over to services or stacks here, we're going to see that new one deploy when I hit the command line. So let's go over here and I'll give it a run. So we'll do a demo 1. And that will shell me to the environment and it will start to create the services. And now let's head back to that UI and we should see, I might have to refresh, an update where we can see it's deploying here, you see? Now, what's the point of that? That's a Compose file getting deployed to have a new application or service deployed. And this is going to show me, what are the services that just got deployed. And it's actually not up yet. You see that? It's trying. It's going to try and bring up 2 of each. And if I go up to the existing stack that was already running, what you'll see is I can go to my services, and I can find the web app, and I can find the DNS to get to it. And it's got that same environment override in the Compose, and I can see that it's working. I can hit the API. And that's just sort of a high-level picture for you there, right? So with that, again, this is the introduction to, hey, how about visualizing some of these things, right? I'm still talking to the master no matter how you slice it. And the other thing that's kind of interesting is in here, I am now actually tunneled in to that cluster. So this is going to show me all the things that are on that master. This is not my local at all. So that's the other thing that's kind of neat in terms of what's your really day-to-day interaction or your CI and CD communication going to look like. You've got options, UIs, endpoints to post and push and deploy and check the status with the CLI tools like this. This is actually just Docker machine, Windows set to look at a different cluster. And that's how that would work with any Docker deployment. Okay, so let's continue. Mesosphere. So DCOS is actually yet another type of environment to deploy application or to deploy your containers to. It's got a master and it's got a set of agents. It's got a different template. It deploys things slightly differently, but ultimately it's the same idea. I've got agents and I've got a master. I have a different API to post to. It's not Docker native. So it's got a different, web API endpoint, HTTP calls to post and schedule. Different format, not Compose, instead some JSON. Doesn't matter. It's specific to that environment, but there's overlapping common things, right, that we need to do. So if we think about that, let's just head into an example, and I'm going to exit this guy, and let's go over to my DCOS. And in the DCOS, let's list my connect files here. So I'm going to do a connect, and that's going to open up port 4555 on my local to touch the DCOS deployment so that I can see HTTP and 4555, right? So this is going to show me a different UI, which is, again, just another visual in front of a cluster. This is the master node UI, essentially, software that lets me see all the services that are running. But let's talk about a couple more orchestration things. We talked about deploying with compose. Now we're talking about compose equivalents. It's not compose, but I still can deploy one or more service with instructions. We also have talked about having command line instructions to see the health of the cluster. We also talked about scheduling slightly. So what I want to do is talk about this conference demo again where I have API and web, but instead, for now, let's just show an example. If I were to deploy a new container, I can go in here, same idea, I'm building my compose right now, right? I'm saying I want this container image, das blonde, and content API. And that's going to go to my Docker Hub and find that container. I don't have any, it's an open public registry, so I don't have to put the security around that, for a demo at least. So this will go under service ID, and I'm going to give this guy a name. So let's go down the process here to, I don't think I need to do that. So go into environment. Environment variables, I don't need any, but that's just another example of where. Health check, very important. So every service you build, you will now add some form of controller with a health check endpoint so that the cluster can know, are you doing well or not? And if you don't return success, then it will know it needs to maybe recycle you or take you out of the load balancer. So that will be an example of something that all of these will set up, right? So I can go to HTTP, I can select an endpoint and call it whack speakers or something like that. And then I can say, how many retries we want, that kind of thing. So every single one of these cluster orchestration platforms will give you the same feature. So we need that. And again, all the rest is just building your compose, essentially, yeah? So this one I would call API 2, and I can just go ahead and try to run that. And it'll give me out of the gate an L4 load balancer inside the cluster. So it's reachable by other services on the cluster and can be scaled to 1, 2, 5, however many instances fit, which is interesting. In order to get publicly facing access, I need my Azure load balancer to send a request into this cluster. And if I don't have something sitting and listening at port 80, then it's not going to work. So what I usually would do is have an HA proxy of sorts. So for example, we can go to the universe package and find Marathon load balancer. So Marathon load balancer. And if I say I want to install that package, let's try that again. It says it's already installed because it's the same name, so I'll just give it another name here. Let's find it. Scrolling, here's my name, LB2, just for the sake of it. And I'm going to do an install. So this would install an HA proxy equivalent, right? It's based on HA proxy in my services, and now we can see deployments are happening. The API looks like it's still trying to deploy, and this guy looks like he's going to try to deploy. And then in the meantime, let's go look at actual services that are running. That's scheduling. It's waiting, it's looking for available resources, it's looking to see if it can deploy or not. And in the meantime, I do have a working example over here. So I can hit my web, and I can go and look at the configuration, and we can see that it's got that environment override, for example, to find my API at L4 load balancer by the name of API. So it's all DNS. It gives you that for free, and I can scale that. As far as the front end goes, I've mapped it to DNS so that I can have multiple things at port 80. So my Azure load balancer sees this, forwards it along. The HA proxy was told this maps to port 10,001, and now all my services, when they enlist, I have to tell it what's my service port. And I pick 2001, 2, 3, 4, et cetera. So that's how we're stitching up to be dynamically scalable within the front end. So just to make sure that you understand, that means there's an extra step, not a bad thing, to get my discovery working. And then in Kubernetes, what you'll find is you don't have to do that because it stitches automatically over to Azure and grabs an IP with DNS. And so that's a beautiful thing. So this is an extra step, not a bad thing, a thing to know because we need discovery We need to be able to distribute these services across and have them be found when we're load balanced. Now, all that being said, with DCOS, I can go through a lot of the same things. I can check my health checks and so on. But what I'm going to do is flip over to Kubernetes to do the same. So we'll take a look at Kubernetes, which again, same idea. I have management nodes and I have agent nodes, right? Only with AKS, the Azure Kubernetes Service from Azure, I don't have to look at the masters or the agents. I will be able to access them. So I can log in, I can use the Azure CLI, I can access the nodes programmatically and deploy and all the things. But I don't have to manage the patching and the updates. That'll all be done by Azure for me, okay? And so it's still a Kubernetes experience in terms of the management UI, and I still have access to that UI, but I get the benefit of not having to do all the other hard work. So let's take a look. And so I'm going to close up my DCOS connection. Away we go. And I'm going to jump into AKS. So with that, I will pop in on my connect. Yeah, that one. And what this will do is get into my cluster so that it'll launch the browser at the Kubernetes UI. And we'll just take a quick look at a couple of things there that are relevant to the discussion here. So again, why do I want an orchestration platform? Scheduling is one thing. Some of those things I just scheduled on DCOS, we're going to just not ever get deployed because there weren't enough resources. But they'll keep retrying is the beautiful thing until something comes available. Think containers that run as jobs that just use available space and then go away. And then everything else is fixed. Like I need my APIs and webs always running. But if they need to scale out, then if there's room, they will. If I need more nodes, I add them, and then they scale again. But the other thing that we like is this idea. If we go into, let's take the same example, this demo, and I have this web app. So with web app, what I want to do is actually go down to my services, excuse me. So services, I have my web app, and this one's at port 80. And Azure provided me the IP in order to get in to Kubernetes. And then I could DNS that. I haven't in this case, but you could. And then this is internally calling the load balancer within Kubernetes to find the API. I didn't have to set anything up for that. That just came for free. You deploy it, you can scale it, it's got its internal access. If I take a look, it looks like it's working. I'm getting to my speakers, I'm getting to my sessions. So let's go back to Kubernetes and let's talk about minimums, right? So this API, if I say I want to kill an instance, and I do that, go back over to services, and actually let's go over to my deployments, and it'll say how many are running of 2, so it will restart if one of them goes away and it needs a minimum 2, it'll actually, go ahead and create that. So I'm always going to have 2 by design. So that's like the self-healing concept, right? Self-healing when there's failure, keep retrying, try to run again. And then the idea of managing a minimum number of instances that are always required. If a node goes down and I lose one, it's going to go try to launch another one over here on another node in the cluster to make sure I maintain that minimum, okay? So the whole idea of retries and restarts, here's another example. If I hit over to, I have an example over here that has a dependency on Redis, for example. So I'm going to hit over to my example that has, let me go to my services, and what we'll see, it didn't change, excuse me. Let's go back to identity. Okay, here we go. So here is Redis, and what I want to do with Redis, I'm going to actually go to the deployments, excuse me, and what we're going to do is take a look at this guy and quickly say, I want to scale you down. Oh, it's still at 0, cool. So here's the beautiful thing about that. When that's not working, when that's not running, and I go over to my services, you can see, if I click on this guy, that one of these is not happy. The reason it's not happy is because Redis is not running right now. So it's expecting Redis, and it's just going to keep trying. So it'll actually do a back-off pull of trying to restart, and then eventually kind of give up for a while and take a longer period, which is intelligent, right? But this guy's still up and running and healthy because I never restarted it, so it hasn't learned that Redis is not there. It's not hitting the dependency. Okay, so reason that's relevant is that if I want to fix that, so this is going to retry to the end of time, and then if I finally bring Redis back, then everything should just work, right? So there's a couple ways I can bring Redis back. I can go in and scale it back to, another number actually, and I would do that over here by the deployments, right? I can go grab Redis. Let me scroll to the next page, and we'll grab it, and we'll say, hey, I want to scale this up so that we have an instance again. And my other service will eventually come back online, right? Oh, insufficient CPU. Well, never mind. So that's a scheduling issue. You see, you're learning so much today. It's awesome. So the other way that I could fix that is I can go over to my, let's head back to where I was, Michele Microservices, core, and let's hit AKS. And what I'm going to do is, if you take a look at how I could script deployment of a bunch of service, last little concept here, I can say I want to update all the services, and this will deploy Redis and all these guys. It's going to redeploy the same task I defined for each of them because I haven't changed it, but that will refresh the service. So if I do an update all, this will start that deployment. And of course, it will need CPU to deploy all of those things if they weren't there already, but these are just an update on the existing services, so that will do a rolling update to each and every one of those. And guess what? I shouldn't care about the order, because I should be defining my microservices not to care. And eventually, all of them get up and running, so if one depends on another, and as long as I don't do silly things like make my health checks depend on an actual API, let them all heal on their own, and then it just starts to work, if that makes sense. So with that, boy, we talked about a lot of things. I think the most important message of all is that if you use Docker and deploy containers, it'll always work on your machine and hopefully everywhere else, including the places that I just showed you. And we talked about different reasons that we need orchestration, the self-healing, scheduling, finding resources, making the best use of resources, load balancing, routing, discovery, but also that you have easy routes with things like PaaS and app services. And now we have the fully managed AKS, which makes that a more accessible thing as well. So hopefully you enjoyed that, and I'll speak to you later. Have a good day. Yeah.